Hey everyone, so to prep us for chapter 17, I'm going to do a video that's a little bit different. So up to this point in organic chemistry, we've talked about acids and bases in terms of organic chemistry. So like pKa's, pH, acid-base reactions, curved arrows, just like sort of isolated by themselves. We haven't talked about the way that they would function if you took those functional groups or those same acids and put them in the human body. But many of you are going on to biochem, and we want you to start thinking about the fact that all these organic molecules that we learned about are actually playing out in real life systems. So today I'm going to show you the Henderson-Hasselbach equation, which is a way that we can think about how some of the acids that we've been talking about are going to play out when we put them in a biological system. So if you don't remember the Henderson-Hasselbach equation, that's okay. This is basically it. It's the concentration of the conjugate base over the acid is equal to 10 to the power of the pH minus the pKa. So if this is our base or our acid, then this would be our conjugate base. So the concentration of this over this is equal to 10 to the pH minus pKa. The pKa of this is 4.7, and the pH of biological systems is 7.3. So we've plugged that in here. So conjugate base over acid is equal to 10 to the power of 7.3 minus 4.7. That's equivalent to 10 to the power of 2.6. I just subtracted 7.3 minus 4.7. So I plugged this into the calculator, and that equals about 400. So the concentration of the conjugate base over the acid is equal to about 400. But if we want to know what that means for the concentration of what the conjugate base is equal to, you have to multiply both sides by the acid, just some basic algebra, and then finally, the conjugate base concentration is equal to 400 times the acid. So for every one acid that's present, there's 400 for the conjugate base. So if you have one acid, you have 400 molecules of the conjugate base. So for every one carboxylic acid that's protonated, you have 400 carboxylic acids that are deprotonated. So although I think as an organic chemist of carboxylic acids in their protonated form, a lot of times in our bodies, carboxylic acids are going to preferentially exist in a deprotonated form. There's going to be a higher concentration at the pH level in our blood of deprotonated carboxylic acid. And that's your organic chemistry to biochem bridge for today. I hope that was helpful to you and that you can kind of start connecting those dots that actually these things that we've learned about on paper for so long are actually also going on in your body, and they'll have a big impact in your biochem class. Can't wait to do more for chapter 17.